Hello everybody. Let's talk a little bit today about electricity. We use electrical devices every day, but what is it that actually makes them work? First, let's define some terms. Three things you'll need to know about if you want to understand electrical things are charge, voltage, and electric current. All electrical things work because there are different electrical charges. Originally, they were just designated as positive and negative to keep them separate. So imagine for a minute that we have a ceiling, and hanging from that ceiling we have two light balls. The balls are neutral, which means they are neither positively nor negatively charged. We typically show this by putting both a positive sign and a negative sign on them. Since they have no charge, they don't interact with each other at all. They just hang there. On the other hand, suppose we replace them with two balls that both have a positive charge. This time something interesting happens. The two move away from each other. They repel. So what do you think might happen if we replace them with two balls that have negative charges? Well, again, they repel each other. So what if we try the last possibility? If we use one that is positive and one that is negative, what do you think happens? In this case, it turns out that the opposite charges move toward each other. They attract. So, here is the first key idea about electrical systems. Like charges always repel each other, but opposite charges attract. Now, can we use that to understand the second big idea of voltage? Well, let's first imagine that we have two large metal plates that are arranged parallel to each other, like this. Next, imagine that you had a superpower, and you had really super magnifying vision, and you had the ability to actually see positive and negative charges. We could see the positive charges spread all around the plates, and they would kind of look like that. But then there would also be negatives, because these are neutral, so every positive would also have a negative charge. They would look like that. Now, where do those charges in reality come from? Well, you have probably learned in other science classes somewhere that everything is made of atoms. Further, you've probably also learned that all atoms have a positively charged nucleus made of protons in the middle of each atom. So this represents an atom's positive nucleus. Electrons have negative charges, and those are in orbit around the outside of the atoms. Since the positive charges are kind of locked in place inside the atoms, it's those movable electrons which are responsible for making electrical systems work. So let's focus for a second on a single negative electron here between these two plates. To begin with, it really isn't affected by the two plates at all because they're not charged. But suppose that we had a way to strip electrons off of that plate on the left and move them over to the plate on the right, like this. Now, this whole plate on the right develops an overall negative charge. We call that a negative electrode. The plate on the left has also developed a charge. It's now positively charged because it still has all the protons that it always had, but now it has fewer electrons to cancel them out. The electron in the middle now feels a force. If we were looking, we wouldn't see any difference at all in the space between that negative electrode and that positive electrode, but the electron would feel a difference. Because it's negative, it would be repelled from that negative electrode on the right, but it would be attracted to that positive electrode on the left. The presence of the separation of charge has created an electric field, and that electron in the middle can feel the effect of it. So how big is it? Well, if we could imagine, if we had a really, really tiny microscopic spring scale, and if we could hook it up to that electron, we would measure the force that it's being pulled with, that is being produced by that electric field. Well, that force is the voltage. So when we talk about a voltage, we're talking about that force that is being produced because of an electric field. You can also probably imagine that if we had a whole bunch more electrons on the right-hand electrode, we maybe could produce a higher voltage or a stronger electric field. Or maybe if we had moved only a very few electrons, we would have a very small voltage and have a very weak electric field. So, to give you an idea, a flashlight battery produces about 1.5 volts, a car battery produces about 12 volts, and many devices in your house work on 120 volts. But the key idea here is that voltage is the force which electrons feel when they are in an electric field. So what are some common voltage sources? Well, we already mentioned one of them. One of the most common ones is just a regular flashlight battery. A flashlight battery has a positive electrode on one end and a negative electrode on the other end, and it's a chemical reaction that separates the charge. Batteries come in many shapes and sizes, from flashlight batteries to automobile batteries to tiny watch batteries. Another source of voltage that you may be aware of are solar panels. These could be very big arrays, or they might be single panels, little small devices that provide just enough power to operate a device like a calculator. A third common voltage source is produced anytime a coil of wire is spun inside of a magnetic field. We call these types of devices generators. And they too could be very small or very large and use different types of energy to make them spin. Finally, you're probably aware of an electrical outlet in your home. Now technically, I guess the voltage source would really be the generator that's back at the power plant that this outlet is ultimately connected to, but you can kind of think of the electrical outlet itself as a voltage source because it provides the separation of charge to operate devices in your house. So, how do those devices work? Well, let's take a minute and think about how electrons can be used to do some work. Let's go back to imagining our two electrodes. Remember, the one on the left is positive, the one on the right is negatively charged. I'm only going to show the electrons on the negative electrode, even though both electrodes have electrons. It's just that the negative electrode has more electrons. And because of this difference in charge on the electrons in space between the electrons is changed. Even though we can't see it, remember that electric field was in here. So electrons that are in that space are going to feel the effect of that electric field. Now normally electrons don't just move from the negative to the positive because they don't move easily through air. Air is an electrical insulator. It takes a huge voltage to push electrons through air. But if we were to run some kind of conductive metal wire between the two plates, we would see that a whole lot of electrons begin to flow very, very quickly. In fact, in a situation like this, so many electrons flow that that wire is liable to get extremely hot. We call that a short circuit when this happens. But instead of a single wire, what would happen if we use two separate wires and we leave a gap between them, like this? Then that gap, we could put a device that uses the energy of moving electrons. A light bulb is an example of something that does that. Now notice when we put it in at the base of the light bulb, the wire that's connected to the negative electrode touches just the tip of the bulb. The wire that goes to the positive electrode touches only the metal base where the threads are on the light bulb. And in between the threads and the tip, there is that black plastic insulator to keep them separate. The voltage is still present, so electrons now still want to move, but this time, as they move, they have to stop and go through the bulb and use some of their energy to do work. In this case, they produce light. So this flow of electrons, which occurs as a result of there being a voltage and a pathway, is called an electric current. So our last key idea is that electric current is the flow of electrons that is produced from negative to positive anytime you have a conductor in an electric field. So let's summarize the key ideas. The first key idea, you have to separate charges to produce a voltage. Anytime you do have separated positive and negative charges, a voltage will exist. In between the electrodes, an electric field will exist. In the electric field, electrons will tend to move away from the negative electrode and toward the positive electrode. And finally, a conductor that is placed in an electric field will allow electrons to flow through it in the form of an electric current.